I'm going to talk today about related rates. So, in every related rate problem, we're going to have these 8 steps that we're going to have to follow. Because in a lot of the times with these related rates problems, they can get pretty complicated, and we don't want to get ahead of ourselves. So what we're going to do is we're going to follow these 8 steps every time. So we're going to go through it. We're going to get from the problem what what's actually happening. So we're going to draw a picture and really visualize what's going on. Then we're going to identify what the actual values that they gave us. Then we need to figure out what they want us to find, what rate that we need to find in these cases. And we're going to want to find an equation relating the variables that we found over here. And then, since we're in calculus, we're going to differentiate that equation. Then from there, we can solve for the desired value that we found in 3. Then, once we see that, we can look through that equation and figure out, hey, which ones did they not give us? What did they not give us in the initial problem? And then from there, after we go through and find all those missing values, we can just plug it in and we'll get our desired rate out. So I'm going to start with this seemingly simple example compared to some of the other ones. What we have here is the problem is a spherical balloon is inflated at a rate of 20 cubic feet per second. How fast is the radius of the balloon changing when the radius is 2 feet? So I'm going to start out with this picture of my sphere here. So I'm going to get that radius in there too. So part 1's done. Now 2, we're going to write down what the given information is. So they say that the spherical balloon is being inflated. So what they want us to know is that's a volume here in cubic feet. So we're going to say dV dt is equal to that 20 cubic feet per second. And they want it when the radius is equal to 2 feet. So we're going to say r is equal to 2. Then for the third part here, we're going to say, what are we looking for? That's going to be right here. How fast is the radius of the balloon changing? So we're going to want the radius, the change in radius with respect to time. dr dt is equal to our question mark here. So then we're going to think, all right, so we have a balloon. They gave us volume. They gave us radius. So what's an equation that's going to relate those? Oh, right, the volume. The equation for the volume of a sphere. So we're going to use V is equal to 4/3 pi r cubed. That'll be the equation that we want. Then we're going to take its derivative. So what we get using the chain rule here, so using the chain rule, we're going to get a dV dt, right? So it's not just going to go away to 1 in these problems. It's going to be each one of these variables is going to be taken with respect to t. So we have to make sure that we get all of these rates of change. So we get dV dt is equal to 4 times that 3. So these 3's cancel when we go through and do this differential. 3, so that it's going to be 4 pi times r to the 3 minus 1, which is going to give us just an r squared, times the derivative of the inside here, our little chain rule, so it's going to be dr dt. So we get 4 pi r squared dr dt. Now, we want to solve for what we said in 3. We want to solve for what we're looking for, right? So they want how fast the radius of the balloon is changing, so we're going to say dr dt. So we're going to solve for dr dt, so that's just simply dividing out by this 4 pi r squared. So dr dt is equal to dV dt over 4 pi r squared. And then we're going to say, hey, do we have any more variables? Let's see. R here, they gave us R, and dV dt, they gave us that. And then 4 is a constant, and pi is a constant. So perfect. Hey, let's just plug it in and solve for what our dr dt is. So we're going to get 20 on top, 4 pi times 2 squared on the bottom. So we're going to get this 4 is going to cancel with one of the 4's up here with the 20, and then just give us a 5 on top. So we're going to get 5 over 4 pi feet per second. Perfect. So let's move on to a little less easy example. So in this problem, we have Calvin and Bonzo driving along parallel roads in opposite directions at 20 feet per second and 80 feet per second respectively. So Calvin's going 20 and Bonzo's going 80. The roads are 200 feet apart, and they want to know how rapidly is the distance between Bonzo and Calvin changing 5 seconds after they pass each other. So like always, we're going to start with our picture. So this picture is just going to be this triangle. So we're going to have the distance between the roads here is going to be this y value. I'm going to say it's y. So that's our 200 feet between the roads. This x value here is going to be the x distance between them, so the linear distance between them. If for those of you who are in physics, this will be your vectors. And then this is going to be that the actual distance between them. I'm going to call it s. So now we want to write down the given information. We sort of did that already. So write down the given information. We're going to say they want it when time is equal to 5 seconds, so t equals 5. And then we want our rates of change for Bonzo and Calvin. So d Bonzo dt, dB dt is equal to 80 feet per second. And then Calvin is d Calvin dt, dc dt is equal to 20. And then we want to say that the roads are 200 feet apart. So my y, like I said earlier, is going to be y is equal to 200 feet. Then the third part, what are we looking for? So it says how rapidly is the distance between them changing. So in this case, since I called this s, I'm going to say ds dt is equal to what we're looking for. That's our question mark here in this case. So then in this equation, since we have a triangle, we're just going to use Pythagorean Theorem. So s squared, a hypotenuse squared, is equal to x squared plus our y squared. Okay? And then we're just going to take its derivative. So that 2 comes down, we subtract 1 off of it, and that's going to be the same for each one of these. We take the chain rule and we get 2s ds dt is equal to 2x dx dt plus 2y dy dt. So then from there, from part 3, we know we want to look for ds dt. So we're going to go ahead and solve it. So we're going to divide by a 2s to get ds dt by itself. So we see that these 2's all cancel, and we just get an s on the bottom. So we get ds dt is equal to x dx dt plus y dy dt all over s. All right. Now, for part 7, we're going to look at our function that we found in the previous step 6, and say, hey, which ones do we still need? So we don't know dx dt, right? We don't know x. We know y. They gave us y. We don't know what dy dt yet, and we don't know s. So pretty much all we know is y. So we're going to have to look at this. So y, since we know it's a constant, the change of a constant, right, the derivative of a constant is just going to be 0. So dy dt is going to be 0. So this whole thing right here is just going to be 0. And then we're going to want to look at dx dt, right? So how fast they're changing in this x direction, right? So we want to look at Calvin's going this way at 20 feet per second, and Bonzo's going this way at 80 feet per second. So the dx dt is just going to be those two added together. Do we see that? So this one, he's going this way and he's going the opposite direction, so they're both just going to get added there. So we're going to get 80 plus 20 is equal to 100 feet per second. All right. So, and I wanted to do dx dt first because we get down to the one that we're looking for x. X in this case is just going to be our dirt formula. Distance equals rate times time. So, but we didn't have rate, but now we have rate. Our rate is just going to be that dx dt we just found. So x is going to be equal to dx dt times our time, which they gave us, right? So we're going to have 100 times 5. So that x distance after 5 seconds is going to be 500 feet. So now we're going to use, so now we want to find s, right? That's the last one. So S we're gonna find using that our original Pythagorean theorem part. So now that we have x and we were given y, we can solve s squared equals x squared plus y squared for s. So we just take a square root of both sides. S is equal to the square root of x squared plus y squared. And then we can just plug in our x and y values and solve for s. Okay? So now we have check mark, we got that one, we got that one, we got that one, we got that one. So we got everything that we need for this. So all we got to do is take all these values that we found and all the given values that they gave us and plug them into our formula. So we go x is 500, dx dt is our 100 plus y, which is 200, but the change in y is 0, so this whole thing's just 0, like I said before. And then s is going to be that 100 square root 29. I know it's ugly, I'm sorry. And that's going to be equal to, so we see if that's 0, then these 100s are going to cancel. We'll just get 500 over the square root of 29. Now, with a lot of these answers, they do not like having a square root in the denominator. So what we're going to do is we're going to multiply by the square root of 29 over the square root of 29, which is going to make this a 29 on the bottom and give us a 29 on the top. So our answer is going to be 500 square root 29 over 29 feet per second. So that's going to be our ds dt. Cool. So now you guys have seen a simple example and a little bit more complicated example. So with a lot of these problems, they can get pretty ugly. So the big thing is just to make sure that you follow each step in this chronological order. I know we're going to get to that first part and see, oh, we're going to have to, we could have said, oh, look, we can find our change in x here and everything, but we don't want to worry about that until we actually have to, right? So we want to make sure that we can get to this formula. So on a test, this is going to get you, once we go through those six steps, that's going to be 6/8 of the problem. So that's going to be most of the points for this test, right? So, or for this problem. So then we can worry about this other stuff later. And then really the big thing is these problems can get long and ugly, but we want to make sure that we follow these steps so that we don't get ahead of ourselves and don't get confused. So once we follow this nice little process, we should be able to little bit easier get to a solution. I'm not going to say they're going to be easy. I've seen some pretty ugly ones. So, all right, I hope this helps, guys. Good luck.